Good morning, everybody. So I'm Pascal Dupont. I'm from Alstom Transport Company, so a French company. This is the French connection this morning. And so Alstom Transport is designing and developing and implementing a rail solution. So for all electrical and mechanical systems, so from the track up to the train, including power supply. We are not doing civil work. And we are not operating the system. This is the job of Bruno to operate later on. So I will focus this morning on tramway solution. I can speak as well about metro, all type of electric train, but the focus will be modern tramway as a kind of follow-up of what Bruno started with. So the aim of the development in new technology today in our activity is really to develop green technology. So to reuse existing materials at rail level, at train level, at every level it's possible. To reduce waste, pollution, CO2 emission, noise, and of course participate to reduce congestion in the city. And we propose as well a solution to reduce cost of maintenance, cost of operation of the system. And so this is a complete cycle that enables us to propose a green solution. One part of that is all the components on board the train is today 98% recyclable. So from the product up to the maintenance at the end of the process, we can recycle 98% of the components. So one of the key topics in the new development is really to reduce energy consumption. So we have a battery of rail solution here. We can focus on the middle one, which is the tramway, where we develop some new motor technology, for example, in order to reduce energy consumption by having better ratio. So I will not go into too much technical detail, but we have technical solutions that enable less energy consumption. So how we can do that, reduce energy consumption? First, the use of the components, of the materials. Improvement of the traction system. So I talked about the motor previously. So we can improve a lot of things at traction level to really reduce energy consumption. Reduction of the weight of the train, of course, contribute to that. And today, tramway allows to reduce energy consumption down by 10% compared to the previous technology. In terms of kilowatt per passenger, today, modern tramway is 4 times more economical than a bus, and 10 times compared to a car. This is exactly the range that has been presented previously. Energy saving solution, it's not only the train. We have developed traction substation, which is the electrical substation that feed the electrical power to the train. So we developed a specific technology in order that we can regenerate 99% of the energy coming from the braking of the train. Tramway, even the metro system, of course, stations are quite close to each other, so the train is accelerating and braking very often. And all the energy that we can take from the braking, we regenerate it in the system. Or we can even sell it to the local power grid, if necessary. Then less particle emission we talked about already, and noise and vibration. So we develop as well some insulation materials, acoustic dampers, so anything that can lead to reduce the noise level of the train. Today the tramway represents 4 times less noise than the automotive traffic. So I will focus on the power supply of the electric train. So why we are looking at alternative power supply solution? Today, traditional power supply is through an overhead contact wire. so a cable on top of the train with a poles with a lot of things that you can see in the landscape around the tramway. So which necessitates a quite heavy infrastructure and not really nice looking. Then we try to find solution to remove that from the landscape. So cities with historical center, with buildings that wanted an alternative to the overhead contact wire. So we want to eliminate everything in the landscape around the train. So of course, it participates to preserve the urban environment, facilitate access in narrow streets, where we have some old building we want to renovate. So it can help to really give a nice environment to the train and preserve the environment of the city. So we developed two types of alternate solution for the power supply of the train. First one, what we call APS, alternate power supply. We can do that on the full length of the line of the tramway. So it's a kind of rail which is underground, embedded in the track, and there is on the train feature that can capture underground the power to give the power to the train. Of course, we have developed a specific interface between the train and the track side, and this can be done all along the line, which is different from the second solution, what we call onboard energy storage system, which means on less than 1 kilometer, we can get rid of the overhead contact wire, but it's limited to 1 kilometer, which means for road crossing, for specific area in the city. Then we store the energy on board the train through two different features that I will develop later. So this can be complementary. We can have overhead contact wire and on some portion of the line, this system. So the first solution, the ground